Hello everyone, this is Manisha Mishra, Assistant Professor in Mathematics and Applied Science Department at St. Andrews Institute of Technology and Management, Gurgaon. And this college is affiliated to Mahasi Dayanand University, Rohtak. So today I will discuss the topic of evaluation of improper integral using Bromwich contour. Right, in our previous session, I told you about evaluation of definite integral, right? So that integral and today's evaluation of improper integral both are different. So first, what is Bromwich contour, right? So let's see Bromwich contour. So the simple closed curve. Okay, just wait a minute. Right. The simple closed curve about which the integration is performed in evaluating is called Bromwich contour, right? So actually we should have a closed curve, and the curve C consists of two parts, C1 and C2, as shown in figure. You can see this figure. This is your x-axis, this one is your y-axis, and this is a closed curve, right? AB is a part located at vertical line and located at distance alpha to the right of the origin, right? So this is your alpha plus pi, this one is your angle alpha minus pi, and this curve is your c1 is moving is anti-clockwise, and this one is your c2 and radius is r here. So the curve C consists of two parts, C1 and C2, as shown in figure. And C1 is the pattern of portion of the circle of radius R centered at the origin. So this is your C1 is the circle having radius R and center at origin. C2 is the vertical line AB located at a distance alpha to the right of the origin. This is your vertical line, right? And this is located at alpha distance to the right of the origin. Integration takes place in the contour clockwise direction. We can see our direction. This is a clockwise direction, right? So by Cauchy residue theorem, so 1 upon 2 pi I for the circle C1 e to the power st fsds plus 1 upon 2 pi I for the circle C2 means vertical line for the vertical line AB e to the power st fs ds is equal to sum of residue of all isolated singular point which will lie inside the circle C. So when r tends to infinity, this is your Bromwich integral method, and when r tends to infinity, that means limit r tends to infinity 1 upon 2 pi I integration C1 e to the power st fsds plus limit r tends to infinity 1 upon 2 pi I integration. Now your AB, for the AB line, AB is moving. Suppose alpha minus pi to alpha plus pi. So there is a variable here alpha minus it to alpha plus it e to the power st fs ds is equal to sum of residue of all isolated singular points inside C. So this is your Bromwich integral, right? Now, which type of question will ask in our final semester exam? This type of questions means evaluation of improper integral. So we will convert improper integral into our proper definite integral, then we will solve these integrals. So if here given integral is in the form of x, so what we are doing just we have to convert our integral in the form of z, like integration fz dz. Now, right after that, by converting our integral into a new integral of in the form of z, then we will calculate our poles. If the poles lie inside the circle, then we will proceed further, otherwise residue will be zero. That means we will calculate our residue at these poles, then we will use a Cauchy residue theorem. So first, evaluation of minus infinity to infinity f1x upon f2x dx, right? This is your integral. This integral is called improper integral. So where f1x and f2x are polynomial in x, right? So such integral can be reduced to convert contour integrals if f2x has no real roots. So this f2x means denominator, right? So denominator, when we will put denominator is equal to 0, then you will get poles singular point. So f2x no real roots. The degree of f2x is greater than that of f1x by at least 2. So wait a minute, there is a figure here and I will explain by the figure. We have considered integration c fz dz. This is your integral, right? So where c is a curve and this one is your curve, and just look at here. We will take semicircle, means upper half circle. We will find our integral value in only in the upper half circle, right? We are not considering whole circle, we just calculate for the upper half or the semicircle. So where c is a curve consisting of the upper half cr of the circle mod z is equal to r. This is a circle of radius r, this side positive radius r, this side negative radius, and this is your half circle and it is moving anti-clockwise direction, right? So and part of the real axis from minus r to r, that means we have to calculate, just try to understand. We are moving from here, that means we will calculate for the cr means semicircle, and also have to calculate for the real axis minus r to r means diameter. We will calculate for the semicircle and also for the diameter. So and part of the real axis from minus r to r, if there are no poles of fz on the real axis, the circle mod z is equal to r. That means for the semicircle and for the radius minus r to r, which is arbitrary, can be taken such that there is no singularity on its circumference cr in the upper half of the plane, right? Then if there are some poles here, then using Cauchy residue theorem. So first you will calculate your residue. So integration c fz dz is equal to 2 pi I sum of the residue of fz at poles within c, which poles will lie inside the circle c. So you will calculate your residue at these poles. Now you can write your integration c fz dz as there is an integration minus r to r. So just minus r to r means you will cover your this region. Minus r to r means diameter. So you will you are taking limit minus r to r and your function is x here. So fx dx plus. Now for the upper half semicircle cr, so your function is fz dz, because this is a circle of half radius. So of radius r. So integration cr fz dz is equal to 2 pi I sum of residues within c, right? This term minus r to r, where it is coming from, you are calculating just your integration value at minus r to r, and here function is fx. So you will write fx and your limit will be minus r to r. Now minus r to r fx dx you can write is equal to minus integration cr fz dz plus 2 pi I sum of residue within c. Now taking limit r tends to infinity. So when r tends to infinity, minus r to r fx dx is equal to minus limit r tends to infinity integration cr fz dz 2 pi I sum of residue. Why we are taking r tends to infinity? Because we have our improper integral. Improper integral means minus infinity to infinity integral. So you will take limit as r tends to infinity. Now if you are taking limit r tends to infinity, then limit r tends to infinity cr fz dz is equal to 0 to pi f r e to the power I theta into r e to the power I theta d theta. So this is nothing but this is your polar form, z is equal to r e to the power I theta, polar complex number. So this is nothing but this polar complex number. Now when r tends to infinity, when you will take the limit r tends to infinity, so first integral will be converted into minus infinity to infinity fx dx 2 pi I sum of residues That means with which line inside the circle C. So that term will be 0. This term if you will take r tends to infinity, so that term will be reduces, and only minus infinity to infinity fx dx is equal to 2 pi I sum of residue will be remaining here. So this sum of residues you will calculate, then put here, and you will get your final answer, right? This is the proof of your improper integral. So proof will not be asked, but there will be a question, and this is your 16 marks, sorry, 15 marks in G scheme. 15 marks question can be asked, and 2 or 3 more questions I will share in our next videos, and that questions also have already come to your semester exam, so I will share. But now let's see this one. So evaluate 0 to infinity cos mx dx upon x square plus 1. So this is your function fx, right? So consider the integral integration c fz dz, where you can write this function as 0 to infinity e to the power I mz upon z square plus 1 dz. So why we are writing I mz? Just look at this one here. We know that e to the power I theta is equal to cos theta plus I sin theta, right? So e to the power I mx is equal to cos mx plus I sin mx, and cos mx is the real part. Cos theta, cos mx is the real part of this, the e to the power I mx. So we can write cos mx as e to the power I mx, and in the last we will write I e to the power I mz as it is cos mz, right? So we are taking our real part. If sin mx is given, then you will also write e to the power I mx, and in the last you can replace e to the power I mx by sin mx. So imaginary part is sin and real part is cos mx. So you are just doing writing, replacing e to cos mx as e to the power I mz. So x is replaced by z because our function for the semicircle function is z. So 0 to infinity e to the power I mz upon z square plus 1 dz. Now fz is equal to e to the power I mz upon z square plus 1. Guys, this part cos mx is a real part, so you can write here e to the power I mz if this is given in the numerator, and if sin mz is given, then you can write e to the power I mz, but that will be your imaginary part, and here this one is a real part, right? Now fz is equal to, we have this one. So here now we can follow our previous method. So taken down the closed curve C consisting of the upper half of a large circle mod z is equal to r, and the real axis from minus r to r means this one, this figure. We are talking about this figure. That means real axis minus r to r and semicircle of radius r cr, right? This here. Now poles of fz are given by, we will calculate poles. So for the poles you will put denominator is equal to 0, then z square plus 1 is equal to 0, so z square is equal to minus 1, so z is equal to plus minus iota. So z is equal to I and z is equal to minus I, both are the simple pole or pole of order 1. So now check which one lie inside the circle. So z is equal to iota, that means x plus iota y is equal to 1. So you will get x is equal to 0 and y is equal to 1, 0, 1. So 0, 1 will lie on y axis, and x is equal to, sorry, z is equal to minus iota, that means x is 0, y is equal to minus 1. So 0 minus 1 will lie on the negative y-axis. So we are not considering negative y-axis. So only one singular point z is equal to I will lie inside the circle here on y-axis, positive y-axis. So we will find residue at only z is equal to I pole. So residue of fz at z is equal to iota, that is a simple pole. So limit z tends to I, limit z tends to I, z minus I into fz, and you will write the value of fz here, e to the power I mz upon z square plus 1. So you can write z square plus 1 as z minus I into z plus I. the z minus I bracket will be cancelled out, and you will get e to the power I mz upon z plus I. Just apply limit here. So e to the power I m into I upon I plus I. E to the power mi square means minus 1 value. So e to the power minus m upon 2I. So this is your residue. Now, if you have residue, then you will apply Cauchy residue theorem. So hence, by Cauchy residue theorem, we have integration C fz dz is equal to 2 pi I sum of residue. So integration C e to the power I mz upon z square plus 1 dz is equal to 2 pi I into e to the power minus m upon 2I. The 2I cancelled out. So you have pi into e to the power minus m. Now, our limit is minus infinity to infinity or 0 to infinity. So we need to convert this integral into 0 to infinity form. So we can write this integral in the form of, now this value is pi to the power minus m. Now we are finding the value minus r to r, that means for the real axis. So minus r to r, we are converting this integral into x function. Minus r to r e to the power I mx upon x square plus 1 dx is equal to pi e to the power minus m. Because in given question we have already minus 0 to infinity cos mx upon, so mx upon z square plus x square plus 1. So for the semicircle, we just change our z x function into z function. So now here we are changing z into x function. So for if you will write x function, then minus r to r limit will be applicable. So equating real parts we have, so minus infinity to infinity cos mx upon x square plus 1 dx. Cos mx, that means e to the power I mx, you can write cos mx. E to the power I mx real part is cos mx, and dx is equal to pi e to the power minus m. You will directly write this integral as minus infinity to infinity. That means you are taking limit r tends to infinity. So now cos mx is an even function, x square plus 1 is an even function. So you can break the limit, and minus infinity to infinity you can break it into 2 times 0 to infinity cos mx upon x square plus 1 dx is equal to this one, and 0 to infinity cos mx dx upon x square plus 1 you can write pi by 2 e to the power minus m. This is your final answer. So this topic is not hard, but integration and 2 or 3 points are here, so just try to understand. And two or three more example I will share in our next video, and I will share an exercise also. So just try to learn, and thank you.